Do you know what time it is? Well, guess what? Because it's math time! It's my favorite time, boys, because we're going to be doing math. So, that being said, today we're going to be talking about some of the most fun you can get into with math, and that's patterns. You know, circle, circle, square, triangle, circle, circle, square, triangle, on and on like that. But with numbers, because, you know, we're not in elementary school anymore. So, that being said, we're going to jump right into arithmetic sequences. And these are really almost as simple as circle, circle, square, triangle. That being said, with an arithmetic sequence, it's in the form of A1 plus N minus 1D. That sounds like gobbledygook. Don't worry, the formula will be jumping up shortly. But when you break it down, all it really means is, okay, we've got this number. You've got a starting number. Let's say we start at 3. And every time you're going to add on 2 more. So you go 3, 5, 7, 9. Not all that scary, right? So we'll break down this formula real quick. Your A1 or U1, depending on which version you're going with, is simply going to be your starting number. That'll be the 3, and that's going to be your first term of your sequence. Then the N minus 1 times D is going to give you your variable amount that you add to each consequent term in the series, in the sequence, so you know which term it's going to be. For example, your first term, because your N term, which is going to be N, the number of terms you've had in your series sequence so far, so that N is going to equal 1. It's the first term. Then 1 minus 1 times D is going to equal 0. So your first term is of course just going to be your U1 or A1, depending on how you like your bread buttered. Then, as you go on, each time your N increases to N2, N3, N4, your number of times you multiply by the increase, which is your D, your difference, is going to increase consequently. So, for your third term, you're going to see you have your 3, your first term, plus N minus 1, and since it's your third term, it's going to be 3. So you get 3 minus 1, 2, 2 times your difference, which is going to be 2. 2 times 2, 4, you have 7. So it went 3, 5, and now 7. And this way you can simply go and compute these sequences instead of having to go all the way down going, okay, let's see, fifth term, it's going to be 3, 5, 7. No, you can punch it right into the equation, it'll be good to go. But what happens if, say, instead of making it a simple, we're going to add something each time, you multiply by something each time, because now things are getting real around here. And when things get real, you know what we call it? Geometry. Dude. So now we're in the geometric realm. And it's not all that geometric in general, because when you're looking at it, it's really just going to be algebraic numbers on a page. It's called geometric because it's expanding based on multiplication. And that being said, a geometric sequence might be something like 3 times 2 times 2 times 2 each time. So your first term's 3. Your next term, instead of being 5, this time you multiply it by that 2 and you get yourself a 6. And then you go on, 12, 24, 48, just like that. So for the geometric sequence, just like arithmetic, there's a nifty formula you can use because you don't want to have to count up the pattern to see where you are. And that nifty formula that you can use is A1 slash U1, which is your first term, multiplied by your rate. The R term is going to be, it stands for rate, and rate is simply going to be what you're multiplying it by each time. So if you're multiplying it by 2, multiplying it by 1/2, multiplying it by 5, that's going to be your rate. And then your rate is going to be to the power of N minus 1. Again, we see that N minus 1, and all that really means is it's saying after your first term, this is going to go into effect. So for your first term, your N minus 1 is going to end up equaling 0. And that means that it's not going to be multiplied by anything, which makes sense when you think about it. Because if you're talking about your pattern being, 3, and then you multiply it by 2 every time after that, well, your first term, you still have to get that 3 out of the way. So once you have that, you just plug it in, and you'll have your 3 times your R, which would be that 2, which is how much you're multiplying it by each time, and then to the N minus 1. So when you get your function for your sequence, what you end up seeing is your f of n, and once you have your f of n, that's going to end up equaling the amount, so you have your initial term, your a1 or your u1, and then that's going to be multiplied by your rate, how much you're multiplying it by each time, And once you multiply it by that, your rate is going to be the power of n minus 1. And there you go, you have it, and you can niftily find each geometric term in your sequence without having to go saying, what's 48 times 2? 96? Now what's 96 times 2? That's gonna get you sleepy real fast, and try doing that 30 times in a row. Not fun. So, next up, we're going to go on to the sequence's big brother. Those are going to be series. Because let's say some sadistic person out there on an island said, you know what we need to do? And somebody else said, hey, what should we do? And they said, you know, after we make these wonderful patterns, each term of the pattern should then add all the previous terms of the pattern, so we create like this monster pattern. And they're like, oh, okay, why not? And they did it, and they created series. So all a series is for example, we're going to start with arithmetic series, because they're a lot simpler, and all it is that you're taking each term, but this time, instead of putting the terms in your series, you're then going to add it to all the previous terms, so that 3 plus 2 times n minus 1 series that we were talking about earlier, well, guess what? Now it's going to be 3, but then when you take that plus 2, you're going to get 3 and 5, but then those two are going to get added. So it's going to go 3, 8, your next term is going to be the 7, so then it's going to be 10, and it goes on like that. But then, remember, for each one it gets added to the previous term. So it gets a little complicated. We're going to show you a few examples later to make sure you really get it understood. But the basic idea is that each time, each term of the series is going to get added to itself. So if you're talking about the basic sequence, 3, 5, 7, 9, then when you add your first 3 terms, it'll give you your third term of a series. And that's going to be the summation of the 3 terms of the sequence. And that'll give you 3 plus 5 plus 7, and that'll give you a nice clean 15. And that's going to end up putting you where you want to be. Now, of course, who wants to do all that work? You know, we got a formula, boys! And our formula for this one is a very useful formula, which is going to be n times a1 plus an over 2. Or, if you prefer it in the form, n over 2 times u1 plus un. All that means, it's your number, which is going to be the number of terms you're talking about. So is this the 5th term, or the 4th term, or the 20th term? That's going to be your number. Your number over 2, and then you're going to go and you're going to find what's your first term. Again, it's just going to be that first term of the series. So in this case, it would be 3. And then you're going to look and say, what's the last term that we're dealing with here? Or the term which is going to be, again, you go back to your original sequences, and that's going to be your u1 plus n minus 1 times d. And once you get that all together, all it is it's really just the simple process of finding your n. Once you know what your n is, and you have that figured out, you divide that by 2, you take that number, you set it aside, you say, okay, we'll come back to you. Then you're going to look back, and you're going to find what your first term is. Find what your first term is, that should be simple. But now you have to say, okay, what's the last term of this series? And when you're looking at your last term of your sequence to find your series, once you're looking at that last term, things get a little bit more complicated. And you know what you have to do? You have to go back to your first equation. So a lot of times it's a lot easier to put this equation in another form that doesn't leave the last term up hanging. And instead, this form is going to be n over 2 times 2u1 plus n minus 1 times d. And what that does is it automatically calculates what your last term is for you without you having to go back and plug it in later. Just keep that in mind. Either one can work, because for example, if you get something like this, okay guys, what you need to do is you need to find your series, and it's going to be the series with the first term being 3, and with the sequence's 4th term being, say, 22. Well, you know it's going to be 3 plus 22, 25, and then you're going to multiply that by n over 2, which your n, that's going to be the 4th term. So 4 over 2, 2 times 25, and that'll give you 50. Pretty simple in that case. But you're not always going to get your last term of your sequence handed to you on a platter when you're trying to find your series. Next up, we're going to go on to, again, It's the big brother. We're going all the way up to geometric because things are going to get funky in here. Remember we were talking about circle, circle, square, triangle? Well, you're going to wish that that was the geometry you're doing once you do geometric series because they get really funky. Think about it for a second. You're talking, okay, we have the 3. So you have this 3 to start off with, and then you multiply it by 2 every time. Except for now you're multiplying it, and then you're adding all of those back together. So just to run through a real quick example, and this is about as complicated as you can get before you have to whip out your calculator and use the formula, what you might do is you start off and you have that 3, first term. Your next term in the sequence remember, is going to be 6, because 3 times 2. But your second term in this series is going to end up being 9, because it's the 6 plus the 3. And then as you go on, your sequence is going to go 3, 6, 12. But then your series, it gets even more complicated because your third term in your series, guess what? It's going to be 21 because it's the 3 plus the 6 plus the 12. And now things are getting really complicated up in here, and it's time for the formula! Woo! And we've got a wonderful formula to help you out here. All it is it's going to be U1 or A1, again, whatever your preference is, times r to the n minus 1 over r minus 1. Let's break it down now. So your U1 slash A1, that's going to be your first term. And in this case, again, for this example, that's going to be your 3. And then you're talking about times that r to the n minus 1. R to the n, r is again just going to be your rate. And in this circumstance, we would be using the rate of 2. That's how much you're multiplying by every time. And then remember, n is going to be the number of terms. So if this is the 4th term, your n is just going to be 4. So now you've got this all worked out. You've got your first term, that's going to be your 3. And it's being multiplied by, in parentheses, r to the n, which is going to be 2 to the 4th minus 1. 2 to the 4th minus 1 will give you 15. Okay, things are still going pretty smooth, so now you have 3 times 15, 45. Now we've got to drop down to the bottom of that fraction because underneath, lurking down below, is never r minus 1. And that r minus 1, again, is just the rate, minus 1. And that rate, again, is going to be 2, because it's how much you're being multiplied by each time. You give that 2 minus 1, and it's just 1. Guess what? You're already done. 45 over 1 equals 45, and you just solved that series. It's just that simple. But remember, use your equation, because if you try to do it in your head, you don't have that much calculating power. I'm sorry, Fred. Just ain't happening. That being said, there's a special type of geometric series that make it even more real. And these are going to be infinite geometric series. Now I'm going to ask you a question. I'm going to be very honest with you. If you keep multiplying a number by 2, say 4, and I say 4 times 2, and then times 2, and then times 2, and then times 2, and times 2, times 2, times 2, times 2, overload. And then you're going to add those all together. Is that ever going to end? Are you ever going to finish that nonsense? You're going to be the dude in a hole, and like the nuclear apocalypse is already going to be happening. You're going to have this long beard, and you're going to be writing your algebraic expressions to try to figure out what this geometric series is doing, because it's infinite, and you're never going to get done. But guess what? We don't worry about those, because those just fly off exponentially and never really come back to Earth. However, there's a wonderful type of geometric series that aren't divergent like that. Divergent, we say, because it expands outward infinitely. We call these convergent geometric series when they're infinite, and they're wonderfully simple to solve. In fact, they're simpler than normal geometric series, believe it or not. So a convergent series would be something, for example, a geometric series in the form your A1 times an r that's going to be between 0 and 1. So for an example, it could be 3 times 1/2 to the n minus 1. That being said, once you have that 3 to the 1/2, as it goes on, your terms are going to become increasingly smaller and smaller. So when you're summing them together, they're going to converge to a particular term. They're never going to quite get there. However, and we'll talk about this later, because limits! You can use a basic limit to figure out what you're doing here. And we'll come back to that later. If you want to see it, you can look into the calculus videos. They're fun. And that being said, you have this wonderfully simple formula, and all it's going to be is a1, remember your first term, good old friend a1, over 1 minus r. 1 minus r, 1 minus your rate. So let's say we're doing that same example, and you're saying 3 times 1/2 to the n minus 1 is your infinite geometric series. And if we want to plug this into sigma notation, that's going to end up being infinity over the sigma. Under the sigma, you're going to have an x equals 1, and to the right of the sigma, you're going to end up having that wonderful 3 times 1/2 to the n minus 1, or in this case it would be x minus 1, because x is going to be your term. And that being said, once you calculate that out, what you're going to find is going to be pretty straightforward, because you have your first term, that 3, and that's just going to be over 1 minus r. Your rate's 1/2, 1 minus 1/2, 1/2. 3 over 1/2 is just going to be 6. Boom! It was just that simple. Remember when I talked about sigma earlier though? Because you're not done. When you're talking about sums, you're going to be using that wonderful fellow sigma. It's got a funky Greek symbol, if you see it, be right over here on the screen. And once you're looking at that, you're going to say, what do I do with that now? I'll tell you what you do with that now. What you're going to do is right above that sigma. You see it? Right over the top. Yep, that's where you put it. You're going to put the number of terms in your series. And this is just going to say that you're going to be summing this number of terms. On the bottom, you're going to put your x, or whatever variable you choose to use, equals blank. And the blank is going to be your starting term. Finally, once you put that in, all you have to do is put your function to the right of the sigma. And your function, that sounds fancy, but all that really is it's the formulas we've been talking about this whole time. Whether it be a1 times r minus 1 times minus n, a1 plus n minus 1 times d, or any other number of them, you just plug in the formula that you're using for your arithmetic series, your geometric sequence, your arithmetic sequence, or your geometric series, put that in right there, and then you can plug that straight into your calculator, and it will niftily figure out what you're doing. Be warned though, you do want to typically, if you're finding the sum of a normal series, plug in the sequence. If you plug a series into something that's already summing, you are going to get an intriguing result, which would be something to the double exponent. And that comes up a little bit later. You don't really have to worry about that for the majority of ever, because they don't really happen that much. That being said, I think we're about done with this, and hopefully you've enjoyed your first math video. Just remember the little brothers and the big brothers. You've got your series. So your series are going to be the top dogs. Beneath them are going to be your sequences. Arithmetic is always going to be a little bit simpler, but don't undersell it, because it can still trip you up. And be ready for this infinite geometric series. You see that r value is larger than 1, throw up your hands and say, I don't care, because you aren't going to be able to find a solution. But if it's smaller than 1, in that nice space between 1 and 0, you've still got a dog in that fight. Just drop that a1 over r minus 1 and you'll be good to go. Have fun doing some solving.